If S is the sample space and E is an event that is contained in the sample space, or a subset of the sample space, then the probability that the event E occurs is P of E equals N of E over N of S. And that notation N of E and N of S means the number of elements in the set. For example, an 8-sided die is rolled. Find the sample space, and then what is the probability of each of the following. So first, the sample space is all of the numbers that could be rolled, all the possible outcomes. So that is 1, 2, 3, 4, 5, 6, 7, and 8. That's our sample space set S. And the number of elements in the set S, or N of S, is equal to 8. So that will be this number when we calculate the probabilities. What is the probability that each of the following occur? A, an odd number is rolled. Sometimes it's a good idea to list out the possible outcomes. 1, 3, 5, and 7 are the odd numbers that are contained in the sample space. So that is the set E. So the number of elements in the set E is 4, which means the probability of the set E, or the probability of rolling an odd number, is equal to 4 over the number of elements in the sample space, which is 8. And we usually reduce probabilities. So 4 over 8 reduces to 1/2. So we have a 1/2 probability of rolling an odd number. Example B, a number less than 4 is rolled. The numbers that are less than 4 are 1, 2, and 3. Note that it says less than and not less than or equal to. So we do not include 4. So for this part of the example, the size of the set E is 3. So that means that the probability that E happens, that we roll a number less than 4, is equal to 3 over the sample size, which is 8. In this case, we can't reduce this probability, so our probability is 3 over 8. Part C, a 10 is rolled. Now a 10 is not contained in the sample space. There's no 10 on the 8-sided die. So what this means is that 10 is not contained in S, so the probability that this happens is 0. There's no probability, there's no chance that we will roll a 10 given this situation.